Hello and welcome. Today, we're diving into the world of 2D arrays in assembly language, specifically using the 8086 processor. 2D arrays, like spreadsheets or grids, are powerful tools for organizing data. Let's explore how we can define, access, and manipulate them using assembly. First, we'll discuss declaring a 2D array in assembly. Remember, assembly deals directly with memory. We'll need to allocate a block of memory large enough to hold all the elements of our array. For instance, if we want a 3x4 array of bytes, we'd allocate 12 bytes. We can use the db, define byte, dw, define word, or dd, define double word, directives depending on the data type. For example, my underscore array db1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 declares a 3x4 array stored in row major order, which is common. Next, we'll examine accessing elements within the array. This is where things get interesting. Since assembly doesn't inherently understand 2D array indexing, we need to calculate the memory offset manually. The formula for calculating the offset is offset equals row number underscore of underscore columns plus column. So, to access the element at row 1, column 2, remembering that indexing usually starts at 0, in our 3x4 array, the offset would be 1 4 plus 2 is equal to 6. We can use registers like SI or DI to store this offset and then use indexed addressing to access the memory location. For example, mov-al, my underscore array, SI, would move the byte at the offset stored in SI into the AL register. Let's consider an example. Suppose we want to set the element at row 2, column 1 to the value 50. We would first calculate the offset, 2 4, plus 1 is equal to 9. Then, we'd load 9 into a register, say SI, and use the instruction mov my underscore array, say, 50 to update the array element. Furthermore, we can iterate through the 2D array using loops. We can use nested loops, an outer loop for rows and an inner loop for columns. Inside the inner loop, we calculate the offset and process the element. Remember to increment the row and column counters accordingly and update the offset for each element. Conditional statements can be incorporated to perform specific actions based on the value of the array elements. For example, you can check if an element is greater than a certain threshold and perform a particular operation. It's important to understand the memory layout, typically row major order, to correctly calculate offsets. Lastly, consider optimization. Avoid redundant calculations of offsets within loops. Store intermediate results in registers to reduce memory access. Understanding these core concepts, declaring, accessing with offset calculations, iterating using loops, and optimization, enables you to effectively utilize 2D arrays in your 8086 assembly programs. Thank you for watching. If you found this video helpful, please consider liking and subscribing. Your support helps us create more content like this. Also, leave a comment if you have any questions or suggestions for future videos.